Today, we are diving into a really fascinating paper, one that suggests large language models aren't just getting good at creating text, they might actually be the new state of the art for judging it. Specifically, we're going to look at how they can evaluate the quality of machine translation, and the results are pretty stunning.
All right, so here's our game plan. To really get why this is such a big deal, we'll first unpack the translation evaluation problem, why judging translations is so darn hard. Then we'll introduce the really elegant solution from this paper, a metric they call GEMBA. After that, we'll look at how they put it to the test, break down its seriously impressive results, and then wrap up by looking at the bigger picture, what this all means for the future. Okay, let's set the stage. For decades, one of the biggest challenges in machine translation has been this. How do you automatically and reliably measure the quality of a translation? It sounds simple on the surface, but trust me, it's a remarkably tricky problem to solve. And that really is the fundamental question, isn't it? You've got a sentence in, say, Chinese, and a machine spits out an English translation. How do you actually score that? How can you tell if it's a solid 9 out of 10 or, a total flop at a 2? Yeah, and historically, the field has been stuck in this classic trade-off. On one side, you've got human evaluation. That's the gold standard, right? It's nuanced, it gets context, but man, is it slow. It's incredibly expensive, and it can even be subjective depending on the evaluator. Then on the other side, you have automated metrics, like the famous blue score. They're fast, they're cheap, they scale beautifully, but they often just don't capture the subtleties of language. They just don't correlate that well with what a human expert would say. Right. So this paper basically proposes a new way to break out of that trade-off. And it's built on a really simple but powerful idea. What if these large language models, which are getting so good at doing translation, also have the built-in knowledge to tell the difference between a good translation and a bad one? And that leads us straight to GEMBA. It stands for GPT Estimation Metric-Based Assessment. The core idea is it's surprisingly elegant. It uses what's called zero-shot prompting, so you're asking a model like GPT-4 to do a task cold, with no examples. You just ask it to score each translated sentence, one by one, and then you simply average all those scores together to get a final quality score for the whole system. Exactly. And this right here, this is the prompt from the method that worked the best, called GEMBA. It's just so simple and natural. You're basically just saying, hey, here's the original text, here's a professional human translation for you to look at, and here's what the machine came up with. Now, score the machine's work from 0 to 100. That's it. So in practice, it really is as simple as it sounds. It just unfolds in 3 basic steps. First, for every single translated sentence, you create one of those prompts. Second, you send it off to the model and get back a score. And third, you just average all those individual sentence scores to get one final report card for the entire translation system. It's that straightforward. Of course, an idea for a new metric is one thing, but proving it works is another. The researchers didn't just propose this, they really put it through its paces. They tested it against the world's best metrics, using a really tough industry standard benchmark. So let's take a look at how they set up this showdown. So for the experiment, they used data from the WMT22 Metrics shared task. And for anyone who doesn't know, that's basically the Olympics for translation metrics. The data set is super robust. You've got 3 major language pairs, over 100,000 translated sentences, and this is the most important part. The gold standard truth is based on these incredibly meticulous error-by-error ratings from professional human linguists. These are known as MQM ratings. And to measure how well a metric is doing, they use something called system-level pairwise accuracy. It's actually a really intuitive idea. Just imagine you have 2 translation systems. We'll call them A and B. The human experts look at them both and say, okay, system A is better. The question is, does your automated metric agree? So pairwise accuracy is just the percentage of times the metric makes the right call when comparing every possible pair of systems. Okay, so we've got the new metric, GEMBA, and we've got this really rigorous test setup. So now we get to the most exciting part of the paper, the results. This is the million-dollar question, right? How did this super simple prompting method actually stack up against metrics that have been developed and fine-tuned over years of dedicated research? The results are, well, they're pretty staggering. Just look at the top of that table. GEMBA, when it's powered by GPT-4, hits nearly 90% accuracy. That's not just a little better, it's a huge leap over these other highly specialized metrics like MetraX and Comet. And I mean, just look down at poor old Blue, sitting there almost 20 points behind. It's just a totally different league. Yeah, let that number sink in for a second. 89.8%. This isn't just an improvement, this is a brand new state of the art. And it was achieved with essentially nothing more than a simple, plain English prompt to a general purpose AI. It's wild. Okay, so that immediately brings up a super important question. Is this some new general ability that all large language models have now? Or is this incredible performance something that's exclusive to the really big, powerful models like GPT-4? And the answer to that is what's so fascinating here. The researchers tested a whole range of models. You can see the smaller, older GPT-3 versions like Babbage and Curie. They did terribly, barely better than a coin flip. But then look at that incredible jump you get with GPT 3.5. It just rockets past the old state of the art all on its own. And then performance just keeps climbing from there with newer models. Right, so the conclusion from this data is totally unambiguous. This isn't something just any LLM can do. This ability to accurately judge translation quality really seems to be an emergent capability. It's something that only shows up in these very large, very powerful models, starting specifically with GPT 3.5 and getting better from there. Now, as incredible as these results are, it's always important to keep a balanced perspective. And to their credit, the authors are really upfront about the limitations of their work, which actually is great because it helps point the way toward what should happen next. For sure. And one of the key nuances is the difference between judging a whole system versus judging a single sentence. So while GEMBA is the new king of the hill for judging the overall quality of a translation system, its performance on individual sentences or segments isn't quite number one, yet. As you can see, it's very competitive, but it's still slightly behind metrics like MetricX and Comment that were specifically trained for that exact task. Yeah, and the paper is very transparent about some other limitations too. Like we said, the state-of-the-art claim is for the system level. The tests were only on 3 very high-resource language pairs. And there's this funny little quirk where the model loves to output scores in multiples of 5, like 80, 85, 90, which can create ties. And finally, there's always that small, nagging concern with any LLM paper that, however unlikely, some of the test data might have been in the training data. Exactly. But what's cool is that these limitations basically create a roadmap for future research. The authors suggest things like moving from zero-shot to few-shot prompting, giving the model a couple of examples to go on, or even fine-tuning a model specifically for this evaluation task could push the accuracy even higher. And there's huge potential in using these models' giant context windows to evaluate whole documents, not just sentences, or even changing the prompts to not just score translation, but to point out the specific types of errors it finds. And that really brings us to the final thought, the big takeaway. This research, it marks a really significant shift. We're now at a point where AI models are not only producing language that's nearly indistinguishable from humans, but they're also evaluating that language at a state-of-the-art level. It really makes you wonder, as these models become both the creators and the judges of language, what does that mean for the future role of humans in the evaluation loop? It's a pretty profound question, and it's one the field is going to be grappling with for years to come.